Two equations. Have you ever heard about the equations before?
Yeah.
Yes. So, what is the difference between equation and the expressions?
I don't know.
Okay. So we know that expressions are something like 2n plus 5, 5x plus 2, 2a plus 3b minus 3. This is all expressions. The equation is,
Oh, expression has something to do with variable.
yes, expression is something we can do with variable and a constant. Yeah? No, variable and a constant. Now, the equation is a little bit different from expressions because the equation is two equal expression. Two equal expression. Something like 2n plus 2 equal 5, or this is equations, or let's say this is number 2. Okay, number 2, or maybe sometimes you see for x minus 2 equals 7. These are all equations. Or sometimes 3n plus 5 equal to 2n minus 2. So this is all equations. Equation is when there's equal sign, the equation is. That is equation. So when equation, there's already equal sign. Okay. Wow. Okay, so this is introduction. Let me explore something on the equation. So, for example, we have okay something to explore on the equation. So, on the way to school, on the way home from school, this is the exercise. On the way home from school, 10 students got off the bus at the first stops. There were there were then 16 students on the bus. How many students students what more than this? How many students were on the bus? Okay, simple question. What? Okay, now simple problems or simple exercise. Yeah. So quite similar to the expression, but equation is the equal expressions. Now we have an exercise called on the way home from school, 10 students were 10 students got off the bus at the first stops. There were then 16 students on the bus.
26.
26.
Wait,
Yes.
yeah.
26 is the correct answer, but how do you figure out the 26?
10 plus 16.
10 plus 16. Okay. So in equation, now how can we write the expression that express this exercise? So first of all, we can, okay, this is the method we write. Maybe you can understand the concept or you can get the answer already in your mind, but this how you can write is let any variable, let's say x, be the total number of students. So how can you write these equations? What do you think? How can we write these equations?
10 plus 16 equals x.
10 plus 16. 10 plus 16 equal x. It should be something like this, but it's not logical. When 10 students got off, meaning that we subtract.
Oh, x subtracted by 10 over
Mhm.
16.
So x subtracted by 10 equal to 16, right? So this is the total number of students. When 10 students got off, meaning that we subtract 10 equal to 16. So this is the equation, the equations we need to solve. Here, how can we solve the equations? So this expression is correct. We can write a correction already. Okay, let me put it as red. Okay, this is the correct equations. Then, now here the problem. In order to solve the equations, okay, the first method is the observation. By I mean the observation is when we observe x equal 1, so we just put random number. If x equal 1, then 1 minus 10, is it equal to 16?
No,
No. What 1 minus 10 is
like it would be negative.
negative 9, right? Negative 9.
Yeah.
So when x equal to
Equals 2 subtracted by 10 equals negative 8.
negative 8, and we know that to get make to get positive 16 as what we want in here, it's maybe bigger number than that. So let's put more random number. Should not put 3. So if for example x equal to 10, 10 minus 10 is still
10 minus 10 equals 0.
0. Okay, so still not the number we want, right? We want is to take x minus 10 to get 16. So let's put more random than that is x equal to 20. Then 20 minus 10 will be
What? 10? 10.
10, yes. 20 minus 10 is 10, but still not the answer we want yet. So
Yeah.
when x equal to 30,
It's 26.
it when x equal to 30, okay, let's try. Like,
Then it's 20.
okay. Then with 30 minus 10 equal to 20, which is more than the answer, right? So initially, like, we haven't know the result yet. But actually, you already know the result. But for example, if we don't know the result yet, so we just put some random number and see Now the result is lower, so we put it more higher. Now when we put more higher, the result is higher than the result we want. So we just adjust them to what the result should be. So when x equal to 26, then it will be 26 minus 10 equal
Equals 60.
16. So this is the result we want. So then x equal to 26. So meaning that the total number of students were 26.
Yeah.
Okay, problem number one. So now let's explore number two. Explore number two. Number two. Janet. Janet. Janet walks totals of 17 kilometer in February. February. February.
Yeah. February.
February, yes. She walked the same number of kilometer kilometers in each of the first 3 weeks. Then she walked 5 kilometers in the fourth week. How many how many how many kilometers did Janet walk in each of the first 3 weeks? Kilometer, kilometer, okay. Now the problem is Janet walks total number of 17 kilometer in February. So let's say this is the beginning of February and the end of February. Okay, from here to here, this is the distance Janet walks. She walked the same number of kilometer in the first 3 weeks. So there are 4 week. There are 4 week in a month. So week one, week two, week three. So these distance, these distance, and this distance, the first 3 weeks, she walked the same number of kilometers, and then she walked 5 kilometers in the fourth week. So the fourth week, she walked 5 kilometers.
Yeah.
So how many kilometers did Janet walk in each of the first 3 weeks? Can you guess? Not can you guess? Like, how do we know? So the total number that she walked in February is 17 kilometers. The first 3 weeks walked the same number of kilometers, and the fourth week she walked 5 kilometer. So how many kilometer did she walk in each of the first 3 weeks? How can we solve this?
I think she walked four,
She walked
like for
four.
3 weeks, and then she walked 5 kilometers. Then
Okay, she walked 4 kilometer is your answer. But how one? How do you figure out the 4 kilometers? How can we?
I
Mm-hmm.
I 3, 6, 9, and then I added up 5, and that went to about 14. But that wasn't right, so I did 4 times 3, which equals 12, and then I added 5 to that.
And then it's okay. So if we can verify if this is four, this is four. 4 plus 4 plus 4 is 12. 12 plus 5 is 17. So if we can verify this is the correct answer. But now here the problem that we need to solve is okay, let me type. I think I can draw faster. Okay, so in order to solve this, first we write the expressions that show the equations. So the expression is for okay. Now we were asked to know how many kilometers did Janet walk in each of the first 3 weeks. So let put it in blue. Let any variable, let's say variable w, let w is or be the number of kilometer Janet walks walks in the first in each of the first 3 weeks. Okay, so we let a variable w be the number of kilometer Janet walked in each of the first 3 weeks. How can we write these equations? For example, now we
What is the total of all of the kilometers Jenna walked in each of the 3 weeks? Like the total?
yeah, but how can we write this equation? For example, now we let w be the number of Janet walked in each of the in each.
5 plus m equals 17. No?
So now we let w be
No.
the kilometer that Janet walked in each of the first 3 weeks. So this distance is w, this distance is w, this distance also
Ah,
w,
uh,
right? So
w times
mhm,
w times
so
3 plus
correct,
5 equals 17.
correct. So the equation we write is 3w or w times 3 plus 5 equal to 17. Okay, this is the equation that we want. 3w plus 5 equal to 17. Now here the problem. Now we can write the equation already. So what we need to do is to solve these equations. To solve the equation, we have several methods. So the first method is by the observing. So observe. Okay, okay, the first method is observe or is observe and technical word it's called trail.
Trial?
Trial.
Trail is TRAIL. LL. Wait, no.
Trial.
That's not,
The tram. Okay.
yeah, that's trial.
Okay, this word. Okay, the technical word we call it trials. Okay, trial. Meaning that we put random number on the variables, then solve these equations. Yeah. So, for example, now we let w equal to 1. When w equal to 1, 3w plus 5 will be 3. So we replace w by 1. So 3 times 1 plus 5, which is equal to
8.
8, which is 4, right? Not correct. So this is 4, so we don't take it. Now when w equal to 2, it will be
2 plus 5.
3 times 2, right? We replace w by 2, so 3 times 2 plus 5, which is
6 plus 5 equals 11.
11. Yes, 11. Still 4,
Nah.
not the correct answer we want. Now when w equal to 3, when w equal to 3, then when w equal to 3
3
times
times 3
plus
equals 9
5
plus
equal to
equals 14.
14. Still not the answer we want, so still false. Okay, so we trials on w equal to 4. When w equal to 4, so we replace w by 4. 3 times 4 plus 5, which is
12 plus 5 equals 17.
17. So this is true, right? Meaning that w equal to
4
4. And don't forget the unit. The unit
is
for
kilometer.
w is kilometer.
4
So 4 kilometer. So this is the answer. Okay, now we can like a little bit understand.
I
Okay.
just bought
Mhm.
I just bought new books today.
Sorry, what did you say?
I just bought new books today.
I didn't.
Huh? I bought new books today.
Oh, you bought Netflix.
Yeah.
Okay, okay. Very nice. So new lesson with a new book. So that's great. That's great. Okay.
I love books.
Mhm. So the another way to solve these equations is right. Another way to solve this equation is by inspections. Inspections. Actually, like this is very similar. Like the way to inspect is now in order to solve 3w plus 5 equal to 17, we inspect actually like it's like we guessing the answer, and we inspecting that if 3 times 4 plus 5, oh this is very accurate, we can write this 12 plus 5 equal to 17. This is how we inspect the equation. 12 plus 5 is equal 17. This is very logics that we can understand. And we can break the 12 to be 3 times 4 plus 5 equal to 17. Then we can conclude that
W equals 4.
W equal to 4. So this is by the method of kilometers. Method of method of inspections.
Yeah.
There are many ways to solve the equation, but now let's come from bits by bits by bits. Okay. Now let's go to a little bit bigger exercise.